Let's settle the score. Grid search versus random search. Which one's best for your model?
Your model's good, but how do you make it great? The secret is tuning its hyperparameters.
But yeah, finding the best settings is a huge challenge. Why? The combinations just explode.
For a standard random forest model, you're looking at over 6 million possibilities. No joke.
So how do you find the best combo without waiting forever? Let's check out 2 popular methods.
All right, first up is GridSearchCV. This is the old-school brute force method. Basically, it builds a grid of every option and then tests every single one. Think of it like trying every key on a massive keychain. You'll find the one that fits, eventually. So yeah, its biggest pro is also its biggest con. It's thorough, but just painfully slow.
Okay, now for the challenger, RandomizedSearchCV. This one's the faster, smarter kid on the block.
Instead of trying everything, it just samples a set number of random combinations. A totally different approach.
It's a bet, right? A good answer now is way better than a perfect one, maybe never.
So you give up that guarantee of perfection in exchange for some serious speed.
All right, main event time. Let's throw them in the ring on the exact same problem. And here's the tail of the tape. You can see the huge differences in speed and strategy.
Okay, the results are in. So who actually won on a real-world task? Let's find out.
Whoa, get this. Random search was way faster and found a slightly better solution. Surprising, right?
So which one should you use? Here is the playbook you need for your own projects.
Here's the golden rule. More than 50 combos? Just start with randomized search. You'll thank me later.
Here's your 4-step workflow. Get a fast baseline, deploy it, and only refine if you absolutely have to.
It all comes down to this. Is a great answer now better than a perfect answer that might never come?